Hey guys, Mr. Goochee here with another chemistry demonstration video. I'm doing anything I can to avoid grading papers and homeworks. So let's get to it. Today we talked about chemical reactions and how you can tell that a chemical reaction has taken place. Now the problem is chemical reactions are when atoms break bonds and form new bonds to create new compounds and substances, but they are so tiny that you can't actually see that happening with your own eyes. You have to look for secondary pieces of evidence, proof that a chemical reaction has occurred. So I'm going to do a real popular chemical reaction that all of us chem teachers love, which is a combination of copper 2 chloride, also known as cupric chloride, and aluminum foil. Okay, so here we go. This stuff looks kind of like a mustard yellow curry powder, and yet when I put it into water, take a look, it turns a lovely turquoise bluish green color. Stir, stir, stir. Stir, 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 right? Like if I were Luke Skywalker, I might be tempted to drink this stuff. All right, yummo. Should we stir it all up? Okay, so how to tell that a chemical reaction occurred. We talked about some pieces of evidence today. Now, for any single piece of evidence of a chemical reaction, there's always some exception you can find. Chemistry is filled with exceptions, all right? And so you want to be looking for a few simultaneous pieces of evidence that a chemical reaction has occurred. Okay, the first piece of evidence that a chemical reaction has occurred is the properties of the substance will start to change. Specifically, looking for a color change is very important. So when I pull this stuff out, oh, gross. Yeah, there's definitely a color change going on here, and the properties are changing as well. Whereas aluminum is normally malleable and flexible, this gunk right here appears to just be kind of goopy looking mess. Now, another thing you can clearly see here is that this thing is getting hot. The water is actually starting to boil. Another piece of evidence of a chemical reaction is that there is almost always a temperature increase, some kind of change in temperature, but usually an increase. A few chemical reactions will actually get colder, but the majority of them get hotter. And this temperature is going up, let's see here, past 100 degrees Fahrenheit, past 120 degrees Fahrenheit, and it's still climbing. Okay, so that's the second piece of evidence that a chemical reaction has occurred. Number one, change in properties, new color, new smell, new taste. I'm not going to drink this, but I assume it tastes different than just aluminum. All right. Piece two, a change in temperature, usually a temperature increase. And the third piece of evidence is it's usually pretty hard to undo, all right, if not impossible. Now, I have no idea how I'm going to turn this brownish colored gunk back into aluminum again, all right? So yeah, this is probably a chemical reaction, all right? Now, again, you want to look for more than one piece of evidence that a chemical reaction is occurring, because you can always find an exception. A temperature change, that's not a chemical reaction. A change in color, that's not a chemical reaction. A chemical reaction that can be changed back easily. You want to keep an eye out for them. Something else we talked about today is different chemical properties, okay? Now, aluminum has the chemical property that's actually pretty unstable, which is why it reacts so violently with this copper 2 chloride solution. But you know, not every metal is like that. So for example, what I've got here is my wedding ring. Okay, let's take a look and see what happens when I dip my wedding ring in a concentrated solution of copper 2 chloride. Nothing. No bubbles, no temperature change, no vapors, no color change. All right, my wedding ring is completely unfazed. And the reason is that my wedding ring is made out of platinum. And platinum, unlike aluminum, is an incredibly stable metal. Its chemical property is it does not react with much of anything. All right. And that's actually why I got a wedding ring made out of platinum, because I expected I'd probably drop stuff on my hands. I'd probably make a mess. I can heal. All right. My ring cannot. So I didn't want to get a ring made out of something that would react violently with the reactants in my classroom. All right. Thank you very much. Have a great day.